Okay, so today we're going to be doing the majority element question, and the question is, given an array nums of size n, return the majority element. The majority element is the element that appears more than half the elements of the array. You may assume that the majority element exists in the array. So, the brute force approach for this would be to just have a counter, and I think in Python there is a library collections where you can import the counter from, and all you would do is just create a counter for each element in the array and then loop through the counter and return the element that has the largest count. So in this case it would be 3, and in this case it would be 2 because 2 shows up more than 1. So that's one approach, but the drawback of that approach is that to store a counter or a frequency map, you would need to have need to store all the elements inside nums, which would be O of n memory complexity. So in this case, a better approach, there is an algorithm, I think it's something voting algorithm, which basically says all you need to do is keep track of one of the elements and have a counter, and anytime you see the same element, you increment the counter. Anytime you see a different element, you decrement the counter. And whenever the counter is at 0, you set the majority element to whatever element you're looking at. So this would work because the question tells you that more than half the array contains one specific element, a majority. So what would happen is that, for example, in this case, the counter would start at 0, and then it would store 3, and then it would always, at each index, it would reset the majority because the counter would always decrement to 0. So, in this case, whatever we return would be the last element because that's 3 and it is a majority. And in this case, what would happen is that the counter would start at 0. It would increment all the way up to 2 because we see 2 2s at the start. But then it would be lost by the 3 1s. We would store majority element as 1 with a count of 3. No, actually it would be a count of 2 because, so this would be from 0 to 1, 1 to 2, and then 2 to 1. Right. So we would have to cancel out the counter. So the two 2s would have a count of 2. The 2 1s would replace it, and the final 1 would leave the counter to be at 1. And the majority element right here in this index would be 1. But then this 2 would cancel out the 1, and the final majority element would be left to be a 2. Intuitively, any element inside the array would be overpowered or replaced by the majority element because its count would be cancelled out by the count of the majority element. And no matter what, at the very end, you would be left with some occurrence or some frequency of the majority element. It might not be the exact number of times the majority element shows up, but it is always going to be some number larger than 0. And even if it's not larger than 0, it's exactly 0. That would just mean we're in this case where the last number was the majority. So I'll show the implementation. That would clear a few things up. So we would have a majority element, which would be our guess for the majority element. And we would have actually that's not even the same as a function. And we would have a count for it, and we would initialize both of them to 0. And then for each num in nums, if count is 0, we just set the majority. And then if And then if majority is the same as num, we increment the counter. Otherwise, we decrement the counter. And then at the very end, what we would be left with is the majority element. So this approach would work. There we go. So the time and space complexity. So as mentioned before, the time complexity of this is O of n, where n is the number of elements. The space complexity of this is O of 1, because we're not using any additional data structures to solve the question.